let everybody know this is being recorded. All right, thank you everybody for being able to make it. Today I do have Trevor with ClearEdge here. We're going to go over some of the tips and tricks with EdgeWise. Once again, introductions. Like I said, we do have Trevor. He's the senior software specialist for ClearEdge 3D. And then myself, Andy Huntley, I'm the scanning technology sales manager for TopCon Positioning. Today we're going to talk about EdgeWise and just some of the things when you're using EdgeWise, how to get more bang for your buck out of it. And at this point, I'm going to go ahead and hand the screen over to Trevor. You on, Trevor?
Find the unmute button. Yes, I am here.
Okay. Screen is yours.
All right, so let me go ahead and share the screen and let me know we can go ahead and get started.
All right, I see your screen.
All right, perfect. So a little bit of introduction as to, first of all, what EdgeWise is. EdgeWise is going to be a scan-to-BIM software solution. What I mean by that is it gives people the ability to take their point cloud data and instead of having to, say, trace it out inside of AutoCAD or Revit, EdgeWise's key strength is that it'll automatically go through and basically using computer algorithms will detect objects from the point cloud data, saving anywhere from 50 to 80% on a traditional scan-to-BIM workflow. So first thing for today, we're going to actually focus a little bit on the automation. Then we'll move into the piping side of the workflow, structural steel following that. And then lastly, we'll round things out with the architectural side. So with that, the starting point of our EdgeWise workflow is going to be the Process Scans button. The Process Scans button is where we can go through and basically choose what workflow we want to use. But we're going to focus over here on the far left, and that's going to be the structured workflow column. And this is going to be when we're using tripod-based scan data. So in this case, I'm just going to go dive in. Here in the bottom right, this is all the various scan file formats we can take. And pretty much what it needs is to be registered, structured scan data. So one of the examples I'm going to use is I'll use a recap project. So I'll go ahead and grab that. And this will take me to my next menu. And this is where I can tell EdgeWise what I want it to create during the automated feature extraction. So starting from the left and working our way to the right, point database. This is where EdgeWise will go through and create the point cloud that we all know and love, that we're all familiar with. What I want to focus in on is this little sub checkbox right here called ClearView. What ClearView is this is where EdgeWise will go through and create photorealistic renderings of the point cloud from a scanner view. Later on, I'll show how we can work with that, but up front, from a processing side of things, it does take longer to process. So practical recommendation is if you're in a rush, go ahead and leave that unchecked. Next up, building, check that box. That's where EdgeWise will go through and extract out walls from the point cloud data. To the right of that, piping, check that box. That's where EdgeWise will go through and automatically detect pipes from the point cloud data. And lastly, to the right of that is ground. This is where EdgeWise will go through and extract out basically like a topo surface or a triangular mesh of the ground surface of the site. So pretty much what the name of the game is here, have the different options checked that you want. It'll give you a quick little summary, and at that point, go ahead and click Start, and then EdgeWise will chug along on the automated feature extraction. So a couple little pro tips. Number one, always process locally and always process over a solid state drive. The reason for that is by processing locally over a solid state drive, you're getting basically the fastest speed that EdgeWise can access the data. The main bottleneck for the processing is going to be the hard drive read-write speed. So the quicker that is, then the quicker the overall processing will go. As far as time goes, on my Intel i7 Alienware laptop, I can do roughly about 100 or so scans in anywhere from 5.5 to 6.5 hours, depending on pipe densities and also wall densities. All right, so switching gears a little bit, now I want to kind of call attention to some of the little kind of miscellaneous ins and outs of the software. So first of all, coming back to the top left is the blank model button. Not only, well, EdgeWise is going to be known for the automation, but there are certain situations where you can actually start from scratch, and this blank model button here is going to be how to do that. This is also the primary way that I can create both ducting models as well as structural models. Skipping one button to the right, we have the Open Model button. The Open Model button allows me to open up any saved EdgeWise point clouds as well as any saved EdgeWise models. Speaking of that, let me go ahead and open up a previous project that I've already done, and that way we can take a look at kind of what would be the result of the automated extraction. So we'll go ahead and open this up like so. So this project, what I'm about to open up here, this is about 20 or so scans. This took me about an hour and 15, about an hour and a half, roughly, the process on my machine. So this would be the starting point for my workflow right here. And again, all these pipes that you're currently seeing up on screen, this is all automatically generated by the software with zero human intervention whatsoever, besides just checking a couple boxes. So a little bit about kind of the starting point for my workflow is, number one, I like to kick things off with something I'll call the rough QA process. That rough QA process is where I'll go over here into the piping tab. And then what I'll do is I'll use my multi-select tool. I'm just going to left click and drag to draw a box around any groupings of false positives like so. That's all it is. Think of this as, again, kind of like a quick scrubbing of my pipes of, again, any obvious false positives that I can find. So a couple of the big tips that I would give users on how to get the most out of this process is, number one, with the clipping or section box. That clipping and section box, that's located up here in the top left in the View tab. So what I'll go ahead and do is click View, and there's my clip tool up here in the top left. So to use the clip tool, I'll change over to an orthographic view, and then have three buttons, X, Y, and Z, and these allow me to snap to one of my different axes. So I'll snap to like my like a plan view right here. I'll then hit Clip. I'll then left click to place a point. I'll left click a second time to turn that point into a box. Then I'll left click a third time, and then anything outside of that box will be clipped out from view. Furthermore, once I do that initial clip, I can come over here, and in the top left, there is an edit checkbox. That edit checkbox right here allows me to have these control spheres that I can then left click and drag to further refine my clip. When I'm ready to go back to work, I can uncheck edit, continue on working where I need to, and then when I want the whole model back, I can uncheck apply, and then everything will return. So that clipping and section box is an especially valuable tool for working in kind of more, I guess you could say, complex piping environments, and that allows me to section out and kind of really focus in on my areas of interest. The other thing is I can use that clipping or section box as a way to kind of section out groups of false positives to protect my good pipes from accidental deletion. The next kind of key little tip that I want to talk about during this kind of rough QA process is going to be the colors of the pipes themselves. We can actually use that to represent different pieces of information. So right now those pipes are colored by the radius in meters, but let's actually talk a little bit about what else we can do. So the first thing we'll do is we'll come over here to the Smartsheet, and then we'll click on the top one right here, the part info spreadsheet. This is an intelligent spreadsheet that links my numerical data back to my visual model. So in here, one of the things I can do is come over here to column settings, and then I can turn on display, RMSE, and coverage. So what this will do is this will add two additional columns to the spreadsheet, RMSE and coverage. So what coverage is a percentage value of how much of that pipe is covered in points. RMSE, on the other hand, stands for root mean square error. That is the distance of error there is in the pipe fitting to the point cloud, or the other way to look at it is how noisy is the data around the pipe. So in general, a good pipe will have a high coverage percentage, meaning a lot of it is covered in points, and a low RMSE value, meaning there's not a lot of error in the fit. As far as what kind of numbers to go off of, and kind of another tip for out in the field, is I would always recommend prioritizing coverage over density. That being said, what I like to use for my metric is about 30. 30% coverage is what I would kind of roughly say is needed for me to have a good extracted pipe. EdgeWise definitely can extract pipes lower than that, but again, just what I've seen kind of from my general modeling, I kind of use 30% as my baseline. All right, now that we have those values loaded, we're actually going to close out of this spreadsheet right here, come over here to the top left into model display, and then we have our color by and then our different options. So for example, if I do color by coverage, I should have a very tropical, kind of somewhat festive looking model. In all seriousness, these colors represent, again, those coverage values associated with the pipes. For green and blues, those are my high coverage pipes. Yellow is kind of like mid coverage, and red are going to be the lower coverage. The reason I want to point this out is because I can use this as kind of a visual indicator to kind of figure out, hey, what pipes are more likely to be false positives. Again, to make this kind of rough QA process off the bat a little bit more guided, so I can quickly identify, again, those false positives. So that is going to be step one of the Edgewise workflow. Again, going through and just kind of doing a rough scrubbing of the pipe model, either using the pipe colors or as well as using the clipping box, basically to kind of help with that whole process. The second step of the workflow is what I like to call the fine QA process. That fine QA process is where we're going to go back over here to the Smartsheet, and then we're going to click the top one right here, the part info spreadsheet. So this time, instead of going into column settings, we're actually going to go ahead and click on the QA mode up here in the top left. So when we click that, what we'll be presented with is the bore of the extracted pipe in gray, and kind of that teal/green, we have all the points used to extract that pipe. So using one hand on the Y key, Y is in yes, I can go through, that'll update the approved column from Node.js, and pretty much what I'm looking for is anything that's not fitting to the point cloud correctly. If I find a false positive, I simply can hit the delete key on the keyboard and it'll delete that pipe from my visual model. Coming back, again, don't be afraid to use those two columns, that RMSE and coverage value, and that you can actually click on the column heading to sort. So right here, here's an example of like a lower coverage pipe. So I'll just hit the delete key on the keyboard, and again, that'll delete it from the visual model. Here's another good example right here of what I'm looking for, and I'll hit delete on that one. So by the end of that process, kind of what we should have is we should have a pretty cleaned up model with not too many false positives. The reason for that is the next big tool, which is going to be step 3 of the workflow. That's going to be the Easy Connect tool. The Easy Connect tool, this is where Edgewise will automatically go through and insert both straight connections as well as elbow connections throughout the model for me. So I'll go ahead and click the tool, and then you'll notice I'm presented with a slider bar. The slider bar allows me to control how aggressive Edgewise will be in kind of going after those connections. Slide it more to the right, it'll do more connections and kind of be more aggressive in the algorithm. Slide it more to the left, it'll only do the connections that it's sure about. The other value, which is the percent diameter variance, what that is a percentage value of how much of the basically how much the two pipes can vary before it will basically won't connect them. So bigger number, more plane to fit, smaller number, tighter tolerance. Pretty much it's to stop the software from accidentally connecting up pipes that should be connected with a reducer. So my big kind of practical recommendation here is the more straight and simple the pipe runs, the more I like to bring this over to the right. The more complex the pipe runs, the more I like to bring it over to the left. That being said, if you're not happy with the results, you can always do a Control-Z, like a Control Undo. Try it a couple times, and then you can always, tweak the algorithm to get a result that you're happy with. So there you can see in black, that's everything the software just did. So all those black straight connections right there, connecting up my pipe runs, as well as we also have our first round of elbow connections. So everything right there, those are going to be default 1.5 bend radius degree elbows. So kind of the now what? This is where we're actually kind of get our hands dirty as a user. This is where we'll come in with the semi-automated modeling tools. So with that, there's going to be kind of 3 main tools that I want to focus in on for today. So the first main tool is going to be what we'll use in areas where we might have a missing pipe. So for example, right here, we have a couple pieces of missing conduit. So the way it works is I'll go ahead and click Extract, which is located about center leftish of the ribbon, and then left click to place a point, and I can keep left clicking to draw a box around the point cloud data like so, and then Edgewise will pull out that object for me. Again, once more, click Extract, 4 mouse clicks followed by a double click, and then Edgewise will once again pull out that second piece for me. So 90% of the time, that's exactly what's going to happen. Draw the box, it'll pull up, it pulls it out for you. If nothing happens, it could be for roughly about 1 of 3 reasons. Number 1, drawing the box too big. If you draw the box too big, it can pull in extraneous data, and that can basically throw off the algorithm. Number 2, the view. the extraction tool works like the human eye in that it relies off the visible points. A lot of the times, if you just orbit the camera around to a bit of a cleaner view, that's usually enough for the software to sort itself out. Lastly, there simply might not be enough points for Edgewise to pull out a pipe. That certainly does happen too. So that is going to be the extract tool. Next up, we have connections. So how to do connections inside of Edgewise? Right above extract, we have the connect tool. So the connect tool is a drop-down menu in that you can do straight pipes and elbows, reducers, and T-joints. So the way it works is we'll go ahead and hit straight pipe and elbow command right here. And we'll have all these little white dots located on the endpoints of our pipe. Simply left click on one white dot, left click on a second white dot, and then Edgewise will instantly stick in the relevant connection. Quite literally, it is a game of connect the dots. The next thing we'll go ahead and talk about is going to be the edit tool. The edit tool is going to be the primary way that I can interact with unconnected piece or interact with basically the different pipes as well as elbows inside of Edgewise. So edit is going to be found in this cluster of 6 tools up here in the kind of top leftish of the software. So the way it works is I'll go ahead and click edit, click on the pipe right here, and then I have these control spheres that I can use to left click and drag to kind of lengthen or shorten the pipe. I can hold down the middle mouse button to drag the pipe in 3-dimensional space, as well as hold down the right mouse button, and that allows me to dynamically adjust the diameter. Furthermore, I can also hit delete, and delete allows me to delete that pipe entirely from my visual model. Coming back, edit also works on elbows, and I can go ahead and click edit and click on an elbow. And then there will be a slider bar up here in the top left that I can use to left click and drag to further refine that. So I can either type in a value or visually with the point cloud on in the background, I can have this and kind of size it to fit. So connect, edit, and extract, those are kind of the 3 main tools inside of Edgewise. And pretty much what I do is kind of go through and I'm just kind of filling in the gaps wherever the automation might have missed anything. That being said, there is one kind of key tool that I want to highlight to everyone's attention, and that's what do we do if we actually don't have any point cloud data? And for that, we're going to talk a little bit about the connect tool and append mode. So if you come back to that connect tool dropdown, you'll notice how it's been this whole time in insert mode. So insert mode is where it's inserting connections in between already existing pieces of pipe. So we can go ahead and use that dropdown and change it to append mode, and now the options will look a little bit different. So append mode allows us to click on the endpoint of a pipe, and it'll go ahead and add a set length of pipe or the connection that we have. So for example, those were straight pipes right there. I can click on an elbow. It'll give me some elbow inputs. There's my elbow right there. Once I have that elbow created, I can then use my rotate tool located to the right of edit, rotate that around, that fitting, and then switch back to going to straight pipes and add on a few more. So that append mode is probably going to be one of the most interesting tools inside of Edgewise, and that again, it allows us to basically build pipes freehand without any existing point cloud data. So that's a really good tool to have in the back pocket, especially if you're kind of working in like a rat's nest of piping, or we might not have significant data where I can go through and that still allows me to complete my pipe runs. So that pretty much sums up the kind of the different semi-automated tools inside of Edgewise. Again, those 3 big ones, extract, connect, and edit, as well as then coming back through using the connect tool and append mode. That way, that allows us to kind of, again, fill any gaps where we might not have any existing data. All right. So just so I can kind of see this a little bit better, let me go ahead and switch this back to my radiuses. We're going to talk about the next tool inside Edgewise, and that's going to be the Clean Pipes tool. So the Clean Pipes tool is a very unique tool in that it allows us to basically control how as-built or how as-designed we want the model to be. And what I mean by that is Edgewise by default will actually capture the different sags and deviations in my pipe runs. The Clean Pipes tool allows me to basically, define whether or not I want a more straight, perfect run, or I can choose it to have more as-built runs. So again, very unique kind of control that I have over my model as a user. So to do that, I'll actually click back to the Smartsheet, and then I want the second one down here, and that's going to be the chain info spreadsheet. So the chain info spreadsheet allows me to see everything relating to the whole pipe run. And at the bottom of that screen is that clean tool. And there we have that tolerance. So that tolerance allows us to do that operation that I talked about. And then if we put a larger tolerance value, we can make a more straight perfect run. Or if we have a smaller tolerance value, it'll make it more as built. In addition to that, the software will also go through and it'll create a new diameter for your pipe runs. That new diameter is a weighted average of all the different sections. The longer a section is, the more it factors into the overall. Think of it kind of like a first pass at standardization. And then lastly, it'll also go through and convert those black straight connections and make those into true pipe. And there you can see in the background, that's our cleaned up pipe run right there. You can also do this for the whole model at once using the big tool to the right of the Easy Connect tool. I'm just going to go ahead and do that. I personally like to do it kind of by pipe run using that Spreadsheet operation. The reason for that is that gives me a little bit more control. So that way, again, I can make, say, some pipe runs more as built than others, as well as I can use where I'm missing those black straight connections as a way to kind of figure out kind of my progress throughout my modeling workflow. All right, and there we can go ahead and see our cleaned up pipe runs right there. All right, now that we've done that, let's go ahead and talk a little bit about standards inside of EdgeWise. So before we talk about how to apply a standard, we're going to take a quick segue over into the File tab right here and click on our Pipe Standard Editor. So this allows us to interact with the actual spreadsheets and standards contained inside the software. So for example, these are all going to be the standards that are contained with EdgeWise outside the box. There's the SME, the American spec, ISO, DIN, a couple Japanese and Korean. So what we can go ahead and do is we can click on one of these, and then there's an export option. So this allows me to export this into Excel. Once it's in Excel, I can edit this table however I want, create my own custom specs, and then I can re-import it back into EdgeWise to use for my modeling process. The other reason I want to point this standard out is because components, valves and flanges. Valves and flanges inside of EdgeWise, they do not drive their dimension off of the point cloud, but instead drive their dimensions off of this component library right here. So with that kind of being said, let's actually go ahead and talk about how do we apply these to the model. I can either go back into that chain info spreadsheet right here, and by clicking on a pipe run, there is a standard column. So that allows me to say I want this to be like an ASME pipe. And this is where I'll change the diameter from what EdgeWise found from the scan data and matches it to the closest standard spec diameter. I can do that one at a time for groups of pipe runs, or by using the big button to the right of the Clean Pipes tool, I can do this for the whole model at once. So I know probably one of the big questions that everyone's asking right now is, what about insulation? So with that, here's my kind of spiel on insulation, and that is, hopefully one of these days, someone makes a scanner that can see through insulation. That would be absolutely lovely. Sadly, that day has yet to come. So with that, we're basically limited by the data, and that data, since it's the outside diameter of the pipe, that is what EdgeWise will be extracting the pipes to. So there's kind of two main ways to handle insulation inside of EdgeWise. Either A, you can export out the outside diameters, bring it into like AutoCAD or Revit, and inside of that end application, you can add the insulation there. Or B, if you actually know the true pipe size of what should be there underneath, you can go ahead and basically using those spreadsheets, manually apply the diameter, it'll change around the center line, and that way you can get your true pipe diameters inside of EdgeWise before you export out into Revit or CAD. So that is insulation as well as standards inside of EdgeWise. Next up, let's go ahead and talk a little bit about components in ClearView. So with that, as I said before, ClearView is going to be a photorealistic rendering of the point cloud from a scanner view. Turn on the scan locations using that checkbox over there on the left, and there you can see the ClearView mode. So this is all point cloud data, meaning all the modeling I have shown and will show throughout our process, we can actually do from this view right here. So using some of the tools that I've already talked about, I'm going to use my edit tool right here to kind of clean this up a little bit. I'll then use my connect tool, making sure I'm in insert mode right there, put an elbow over here on the left. I'll throw some T's, so I'll T on the left, T on the right. And now we have two valves. So there's two drop-down menus. Here's a drop-down menu of all the different valves. Above that is all our different flange components. So choose the one we want. I'm just going to do like a flange gate for demonstration's sake. left click and drop, and wherever you left click, it'll place the component at that spot. Once we do that, we can then use our rotate tool right here, left click and drag, rotate these valve handles around. And then we also have a slide tool, and we can use to left click and drag and kind of visually place that as a user. So that is going to be component placement inside of Edgewise. Again, click and drop according to the point cloud as a user. Later on, I'll actually show one of the biggest tools inside of Edgewise that actually helps with that process. But again, I'll kind of leave that one towards the end. All right, so I'm going to go ahead and get out of ClearView by going into the View tab, uncheck the ClearView mode, and then let's return back to our 3D mode right here. All right, so last but not least, let's talk about a little bit more about that chain info spreadsheet in depth. So as I mentioned before, this allows you to see the information relating to the whole pipe run. So this is where we can also assign layer information as well as define our Revit families. So we can export into Revit as one of three. We can do pipe, conduit, and duct, and this will ensure it'll come into Revit under that correct family database. Also at the bottom of the screen, there is a multi-edit tool. The multi-edit tool kind of does what the name says, and that allows me to kind of sort by diameter. So I can grab everything. Let's say we want to grab everything under about 50 mil or 2 inches right here. I can then go multi-edit, go to my Revit families, define this all as conduit, so that will come into Revit under that conduit family database, as well as I can come through over here and define this to a layer. So if we want like a conduit layer right here, totally just misspelled conduit, I think. Yep. And now we can actually use that layer information inside of Edgewise with this tool in the File tab, and that's going to be the Merge Split. So the Merge Split tool right here, this is where I'll actually take my global pipe model and we'll split that pipe model into sublayers. And we'll create a basically a kind of sectioned out pipe model only containing the pipes in that layer. So if I go ahead and run the tool, I can come back to it and I have merge underscore and then my conduit layer. I'll go ahead and open that back up. And you'll see that's going to be overloaded over here on the left here shortly. And now if I click that, there's my pipes, or there's my conduits, I should say, completely isolated from my main model. Now that I have this separated out, I can export this separately into CAD, Revit, or whatever end application I'm going into. And that way I'm not dealing with, say, the whole model, I'm just dealing with the pipes. And this allows me to kind of more easily, I guess I should say, map my different families or my different layers over from Edgewise into my end application. Speaking of that, let's actually go ahead and talk a little bit about popping these out and what we can go into. So number one of the biggest exports we have and closest integrations is going to be with Revit. So right now we support Revit 2020, 2019, and 2018. Additionally, the coordinate system. Edgewise will use and export all models to whatever coordinates are defined during the original registration process. So that way, as you model your different, say, piping, your structure, you can bring those into Revit, one on top of the other. And as they come into Revit, everything will be correctly aligned. And then you can say, bring in the point cloud by shared coordinates. That'll all come in and then save it out as a Revit project. At that point, once you save it out, there's, say, no link back to Edgewise. So that way you can then hand that on to your engineers, your architects, the detailers, and they can basically finish off from there. Additionally, right here, there's also exports out into CAD and various other platforms. So for intelligent exports, we have integrations with Plant3D, PDMS, and CADWorks. For going into more generic CAD formats, say, for example, just vanilla AutoCAD or like SolidWorks, we have STEP, and we can also export out the center lines and the routing lines as DXF files. Lastly, for the exports, there's 2 point cloud exports. The first one I want to talk about is this one called Smart Points. Smart Points is export out the point cloud data associated with certain objects inside of Edgewise. So for example, like pipe runs, pieces of steel. And the way it works is I'll set like a search distance, so like 2 inches or a couple centimeters. And then Edgewise will go out to those objects and grab just the point cloud data around them. So that way, in the end, what I get is a clipped out point cloud only containing, say, immediately the points that are associated with my pipes. That way I can then bring that into Revit or CAD and then use that as a guide to model instead of having to deal with the whole, say, congested point cloud. There's also the opposite of that called remainder cloud. And remainder cloud is more or less where Edgewise knows all the modeled point cloud data. Now, remainder cloud is an export of all the remaining points, or everything that say still needs to be modeled inside of your end application. So again, both of those point cloud exports, that's kind of designed to help facilitate the modeling in your end process. Since Edgewise, it can do a lot, but it can't do everything. And so that's why those two exports exist there. And that pretty much wraps up the piping side of the workflow. We're going to take a quick question break right here, probably for about 30 seconds. Feel free to either ask your questions by unmuting, or you can go ahead and type the questions into the meeting chat and I can answer them there. All right, if there's no questions, let's go ahead and talk about the structural portion of the software. So the structural portion of the Edgewise software actually operates off of a different engine, and that engine is going to be object detection. So what I mean by that, and kind of the big practical step, is that instead of the automation happening at the beginning of the software, the automation is more going to be happening at the end. So the starting point for the structural portion of that software is I'll go blank model, create a new structure model right here, click on the structure model to make it my active, and then here are all my structure modeling tools. So the centerpiece is going to be my extract tool right here. It works exactly the same as with the piping side of the workflow, and that we draw a box, and then Edgewise will go ahead and pull that object out for me. Unique to structure is going to be the 3 drop-down menus located to the left. The first one is going to be the catalog. When the Edgewise structure portion actually does an extraction, the way it works is it'll go ahead and browse a steel catalog and then choose from that steel catalog the member size that best fits. So in addition to steel catalogs, we also have wood and concrete catalogs for doing, say, wood beams and concrete supports. Lastly, those catalogs are fully editable. They're more or less just Excel spreadsheets. So if you're dealing with either historic structures or custom sizes, you can go ahead and add your own. Next up is type. So we have I-beams, round tubing, channel angle iron tubes and Ts, as well as cylindrical and rectangular concrete, and then rectangular wood beams. And then lastly, the size. There's the auto fit, as well as all the different sizes contained in the catalog right there. So my kind of big pro tip is I like to come to my first kind of piece of steel. I like to make sure it has plenty of point cloud coverage right here. I kind of come at it a little bit, kind of like in a perpendicular view. Click extract, draw the box like so. Once you have that box drawn, then double left click, give it a sec. And it's going to go ahead and browse that steel catalog and then choose the catalog size that best fits. And there you can see is my first piece of steel right here. Now that we have our steel extracted, let's go ahead and talk a little bit about item manipulation. So we can left click and drag if we just want to drag the steel anywhere in 3-dimensional space. The other thing we can do is we have these arrows. So let me zoom in here real quick. So these arrows, we have the 2 on the ends of the steel, allow me to lengthen or shorten the beam. And the 3 smaller sets are the side draggers. So these only let me drag the element in that plane. So these are really good for doing fine-tune manipulation. I can also delete, copy and paste, that works too. But I'm going to go ahead and Control-Z a couple times and then put this element back. Oops, too far. And we'll talk about the next thing, and that's going to be the QA/QC tools inside the software. So similar to the piping, there is also a Spreadsheet located in the structural steel portion. So the way it works is we'll go ahead and click the Spreadsheet option right here, and then we have 2 things. At the top, we have a spreadsheet with all our numerics, so I can see the length information, the standard, the size, and then over there below that, I have the 2D view. Inside the 2D view, I have all the point cloud data in green, and then that white, I have the outline of my element. So in here, I can left click and drag to manually manipulate the element, as well as I can hold down the shift key, drag to the left and the right, and that allows me to roll the element on its side. Coming back, I'm just going to do this for demonstration's sake, and that's basically change the size to something incorrect to say, hey, what would happen if, something went wrong, or maybe we had an incorrect extraction. It's a Friday, maybe I got a little bit lazy drawing my box. So the way it works if I do have an incorrect extraction is right here, kind of at center rightish of the ribbon, that's the resize tool. So the way the resize tool works is click resize, come over here to the 2D view, and then left click and drag to draw a box. So you drag it from one corner to the opposite corner, let go, and then Edgewise will instantly try to resize it. At that point, once you do that, you have thicker and thinner located directly below the resize tool right here. And you can click the tool a couple times, and that allows you to cycle through the adjacent steel thicknesses. That way I can kind of further refine the fit. So right about there. Maybe one more. All right, perfect. So we've gone through, we did our first extraction. We're happy with it. We've QA/QC'd it so we can verify this is the correct piece of steel. And so now we can take advantage of the fact that structural steel sizes are often repeated throughout a project. And we can do that with this tool right here called Set to Selected. So Set to Selected will put a true size wherever the auto fit once was. So now that we know that true size, we can almost kind of go like rapid fire. Since Edgewise knows the size, we can go into areas where we might have, say, poor quality scan data. Pretty much what the software will do is it'll just kind of yank out our beams for us. Basically, it makes the extraction algorithm a lot more robust since it doesn't have to browse that catalog each and every time. It simply knows the size we want and will go ahead and just pull it out for us. So there you can see it's about 7 more beams in roughly about 15 to 20 seconds. Switching gears a little bit, let's go ahead and talk about concrete. So concrete pretty much works in the exact same process. Switch over to a concrete catalog right here. Draw the box. So I'll do something like this, double left click. AQC, I'm pretty happy with that. And then use that Set to Selected tool. Oops. Go ahead and pull out a couple more pieces of concrete. So I'll grab like this one, and we'll grab a couple here in the back. So another quick pro tip is notice how I'm not drawing full boxes. There actually is a reason for that. And that reason is the next tool that I'm about to talk about, and that's going to be the Extend tool. The Extend tool quite literally does what the name says. Click a bunch of items, click Extend, and this allows you to extend them over to a face. So I can click Extend to basically go up and down. I'll then grab these horizontal beams, extend over and over. And this quickly allows me to kind of build a section of my structure. And now that we have this section built, this is where the automation actually comes in through something called the Pattern Extract tool. What the Pattern Extract tool is think of it, well, what it is basically where I can define a direction and a spacing. And then what Edgewise will do is it'll go out at that set direction and at that set spacing for whatever objects I tell it to, and we'll look for those objects in the point cloud. If it finds the object, it'll do a true mass extraction, fitting each one individually to the point cloud to get you your as-built conditions. Think of it like an intelligent array tool that instead of just doing a blind copy and paste 10 times every 10 meters or 10 feet, it'll actually leverage the point cloud data to do individualized fits. So I'm just going to do it like one beam real quick. So I'll grab that beam. I'll then hit Pattern Extract, use the beam on the right, and then click on the one on the left. That tells it direction by clicking from right to left. And then the direction of, or the spacing of the algorithm, that's determined by the two that we click. So what you just saw there is actually something very important, and that's if the algorithm stops. If the algorithm stops, could be for about one of two reasons. Number one, not enough point cloud data. If there's not enough point cloud data, it'll stop itself so that way it doesn't risk making a mistake. And number two, if the pattern as it continues through space is that varies too much from the original scan data, it'll actually drop elements and stop itself. And that's its way of trying to get your attention as a user to say, hey, something's going on over here. You might want to take a look. So as I kind of continually do these sweeps, I can go ahead and pattern over to the left. Now I've done that pattern over to the left, I can then go ahead and grab my concrete beams and then pattern them over to the right. And again, by doing this almost printer head approach, this quickly allows me to kind of build up my different elements, and that way I can do multiple sweeps and basically knock out my whole truss. At that point, once I have that all modeled, I can do one final QA/QC check using that Spreadsheet. And I'll come over here into the File tab. Right here is the exports. So again, we have basically exports into CAD using STEP, as well as if you have any clients using PDMS, we do have an intelligent PDMS plugin that allows it to go in as intelligent objects. Same with Revit. Any steel detailers or steel subs using Revit, all this will come into Revit as true structural steel. It'll be Revit intelligent steel that they can then do with it what they will, add any further details. So that is going to be the structural portion of the Edgewise software. Once again, we'll take a quick 30 seconds for about questions, and then we'll actually move on and talk a little bit about the rectangular HVAC side of the software, and focus a little on that before moving and lastly finishing off with the architectural side. All right. If there's no additional, or if there's no questions, let's actually talk a little bit and take a look at the HVAC portion of the software. So rectangular HVAC, that's actually been one of the, I guess you could say that's been one of the most interesting sides of the Edgewise software, in that it's basically a big pain to model that in Revit. With the this module of the software, it allows you basically to speed up HVAC modeling tremendously. So here's going to be my starting point right here. I'm just going to switch gears and load in this point cloud. And there you can see is a nice kind of complex duct right there. So let's go ahead and talk about how we can model this real quick. So similar to the structural portion, instead of, we'll now create a new duct model right here. Click on that duct model to make it the active. And then here are all my duct modeling tools. Notice how everything looks very similar to the structural portion of the software. Again, that kind of relating back, both of them use that same object detection engine. So with the structure, or with the ducting side, to begin, if I can extract out my straights, then Edgewise will do the transitions and the elbows for me. So I'm going to extract out my first base piece right here, click extract, draw my box, double left click, give it a sec. And there you can see is that first piece right there. The next thing is any complex geometry like this S shape right here. If I can break that down into what Edgewise can do, so either radius elbow, mitered elbow, or so on, then Edgewise can, or then it makes it kind of fair game for my modeling. So I'm going to break that down into two radius elbows with a small little straight piece connection in between. So I'm going to whip around to the back here and we'll get a straight. I'm going to size that down like so. And I can always verify my checks using that Smartsheet. Again, similar to the structure, I can see, oh, that's a little bit too small. So I'll quickly come over here, use my resize tool, resize that like so. And I am happy with that. All right, and lastly, let's go ahead and get this top piece right here. Perfect. Now that I have my straights extracted, we'll talk about the next step of the workflow, and that's going to be the alignment phase. So the alignment phase of the workflow is where I'm going to use my snapping tools right here, and I'll first do a snap parallel to align my top piece with my bottom piece. Then I'll do a shift select, do a snap aligned, click on my base piece right here, and that'll rotate the four corners of the ducts, ensuring that everything will come in nice and smooth. Now, connections. For connections with a pair of ducts selected, I'll come over here to my top right, and I have my connection options right here. So I'll do like an add transition with a radius elbow. Click, and there you can see my pieces coming in. I'll then move on to the next pair of ducts. Click once again, and there's them, my completed run. Now that I have my run completed, I can turn the point cloud back on. And then I have these large manipulator areas that I can use to left click and drag, kind of push and pull my ducts, again, fitting that to the point cloud. And that's looking perfect right about there. I can always ensure that I have full connectivity before exporting by doing a tab selection. We're looking good. And then I can go ahead and export this out into my end application. So either Revit as full Revit family ducting, or we can bring it into CAD as three-dimensional solids, and the connections like the elbows will come in as a polyface mesh. So that is going to be the ducting portion of the software. So once again, take a quick 15 to 20 seconds for any questions, and then we'll move on to the last bit of the EdgeWise software, and that's going to be the architectural or building module. All right, so I'll kind of tee up and talk a little bit about the last portion of the software, the architectural side. It's actually designed to work with Revit. So I'm going to go ahead and fire up Revit in the background, and then let's go ahead and take a look. So similar to the piping, the architectural side, what it'll go ahead and do is you run it through the software, and automatically it'll spit out something approximating this. So we'll have our point cloud created, and then it'll also go through and extract out that drop. So it'll also go back through and try to extract out my walls. So that would look approximately right about yay. So there's my point cloud, and if I go ahead and turn that off, these are all the walls that the software found, again, automatically for me. So this is kind of the true intent of the EdgeWise architectural side of the software. It's to support a quick kind of floor plan mapping workflow where I can go through, quickly find the as-built conditions of my walls, and then bring those into Revit. So speaking of that, let's go ahead and actually pop this out and take a look at the Revit integration as well as the enhanced Revit plugin. So I'm going to save this out to my desktop right here. So in addition to writing the wall geometry, EdgeWise will also write out the point cloud data associated with those walls. And what it does with that is it's going to actually go through, and using the plugin inside of Revit, we can display that as a heat map. And so that heat map allows us to see a lot more of, I guess you could say, these subtle as-built conditions on our walls. So I'll go ahead and pop that out. Let's switch over to Revit real quick. I'm just going to open up a new architectural template. And there you can see in the top right, we have our EdgeWise import. So let me go ahead, I'll grab that file. And here you can see is our import options. So working from the top and working our way down, number one, level mapping. With that, for the level mapping, if we actually have our levels already set up inside of Revit, we can map the EdgeWise created ones to the ones that already exist. Below that, we also have snapping tolerances. What that is we can basically control whether kind of the angles that the walls that EdgeWise creates. What I mean by that is no architect is going to want to see like an 89.5 degree wall. They want 90s. So we can use this plugin right here basically to kind of round off some of those strange numbers, if you will. So that way our model will come out a little bit more as designed and friendlier to the architects. Lastly, wall thickness. With that, if EdgeWise actually has both the inside and the outside set of wall scan data, it'll try to extract it to the true thickness. If it only has one set of scan data, it'll just extract it out to the default Revit thickness of about 5 inches. So I'm going to go ahead and start the import. And then this will, again, bring all our walls over from the EdgeWise over into Revit. All right. There we go. So now let's go ahead and link our heat map of the walls. So I'm going to go ahead and turn this back to a wireframe real quick. And now I can do a color by distance. And there you can see it. So green is good, where I have a good fit of my wall to the cloud. Blue is going to be points that are too far on the inside face of the wall. Yellow is going to be points that are too far on the outside face of the wall. So again, very quickly I can check to make sure how are my fits. If I'm not happy with a fit, I can then use my refit wall tool and choose how I want to refit this wall back to the point cloud. I can either do the original wall, which is going to be what EdgeWise brought in. I can do the best fit plumb, where it'll take that wall and fit it back to the cloud. Or I can do an as-built face. In the as-built faces where we'll do that, but in addition to that process, it'll go through and actually create a rectangular mass object. And that rectangular mass is how EdgeWise will try to capture the vertical slant of the wall. Lastly, coming back to that smart points export, I can use those smart points export out with my walls. That actually will be popped out as a recap project. So if I brought that in, it would look something approximating like this. So there you can see is just the point cloud data immediately belonging to those walls. And this is a very powerful tool that allows me to kind of help facilitate modeling my openings, such as windows and doors. So at this point, as I've said previously, I can save it out. This is a Revit project, hand it over to the engineers, architects. Again, this is all full Revit family walls that I can then work with here. It's however I want to do it. So that pretty much wraps up the architectural side of the software, as well as that basically covers the EdgeWise product or the EdgeWise modules there. So any final questions or comments about anything anyone's seen today?
Hey, Trevor, so we're talking about point cloud data. How dense does our point cloud need to be for EdgeWise to work with it?
So that depends on kind of what you're trying to model. So for example, larger pieces of structural steel or like wall surfaces, you can have a lot less data because those are basically a lot bigger objects. Smaller pieces like pipes, like smaller conduits, stuff like that, then I would definitely say you need more data just to ensure you have that good amount of coverage and enough density to trip the algorithm. So again, kind of depends on what you're scanning. In general, I would say going with roughly, for example, the GLS, if you're just scanning in general, using about I think it's called the detailed resolution or the detailed scan setting at I think it's like a 6mm at 10m resolution, and setting up maybe once every about 10 feet, maybe 15 feet. That should be plenty for working with EdgeWise. Any other questions about anything anyone's seen today?
Okay, if nobody else has got any questions for today, I want to thank everybody who could attend for coming out. If you do have questions later on, I ask that you please get with any of your TopCon representatives. We'll be more than glad to help you guys out. And with that being said, thank you and have a good day.